Alrighty, children, I just want to be sure you are ready for tomorrow's test. So let's have a look at a couple of problems from the test review that I gave you. Here's number 1. 5x plus y is equal to 2. You've got a couple of options here. This is in standard form and you're being asked to convert it into slope-intercept form. So you could start by subtracting 5x from both sides, which leaves us with y equals 2 minus 5x. Of course, standard form is y equals mx plus b, so we would want to change the order to negative 5x plus 2. But that's not the only thing you could do here. You could recognize that the value of a in the standard form equation is 5, and that the value of b is equal to 1, with the value of c equal to 2. And then you could use your identities for slope and for y-intercept. So if you check your notes, you'll see that slope is the opposite of a divided by b, and that the y-intercept is c divided by b. So that'll work just as well. And how about number 2? Again, given an equation in standard form, 3x minus 6y is equal to negative 18. You could start by subtracting 3x from both sides, which will leave negative 6y equal to negative 3x minus 18. I'm going straight to the correct order for slope-intercept. And then you can divide each term by negative 6. 6's cancel, leaving y equals negatives cancel, and 3 6 reduces to 1/2 x. Negatives cancel, so 1/2 x plus 3. Here's a mistake I saw some people making in class. When they divided both sides by negative 6, they did not divide every individual term. So let's just do a little experiment. Let's say instead of the equation that's on the screen right now, you have 10 minus 8 equals 2. I think anybody would agree with that. Now let's divide both sides by 2, but let's only divide 8 by 2 and 2 by 2. 2 divided by 2 makes 1, the 10 comes straight down, and negative 8 divided by 2 is negative 4. And then let's take the same equation, but divide every individual term by 2. 10 divided by 2 is 5, 8 divided by 2 is 4, and 2 divided by 2 is 1. Clearly this is correct, and this is not. So when you're dividing an equation by any number, or multiplying from that matter, you need to let the division or the multiplication act on every individual term in the equation. And number 4 is a great place to take advantage of what I just taught you with multiplication. You're asked to put this into standard form. It looks like it's a standard form already. You could switch it around and write the negative 4x plus 2y equals negative 5 if you want. It's definitely a step in the right direction, but the real problem here is this negative sign in front of the 4. A has got to be positive and whole. Can't be a fraction, can't be negative. So to get rid of a negative, we multiply by negative 1. But if we're going to multiply one term by negative 1, we've got to multiply them all by negative 1. Remember what we learned by distribution. Negative 1 times negative 4 makes positive 4x. Negative 1 times 2y makes negative 2y. And negative 1 times negative 5 is positive 5. And there you go. That is a standard form equation. You can do something similar in number 5, where you've got 1/8 x plus 2 plus y is equal to negative 4. Well, we know for standard form we want something times x plus something times y equals some number. So let's start with that negative 2, or with that positive 2. Cancel that out by subtracting 2 from both sides to get 1/8 x plus y equals negative 6. Now the problem is the fraction, the 1/8. Well, we talked about this in class today. How do you cancel a fraction? You multiply by the reciprocal. The reciprocal of 1/8 is 8 over 1. So let's multiply every term in this equation by 8 over 1. It might help to see that in a little more detail. We've got 8 over 1 times 1 over 8x plus 8 over 1 times y over 1 equal 8 over 1 times negative 6 over 1. Cancel the 8's, leaving x. 1 times 1 doesn't change anything, so we've got 8y. And 8 times negative 6 is negative 48. On number 9, don't be scared of the fractions. Use the same technique we've been learning for finding x and y intercepts in standard form since the beginning. To find the y-intercept, let x equal 0. 0 divided by 4 is 0, so that leaves 3y over 5 equal to 1. Multiply both sides by the reciprocal. This is 1 over 1 if that helps you. 5's cancel, 3's cancel, leaving y equals 5/3. So the y-intercept there is when x is 0, y is 5/3. See if you can find the x-intercept on your own if you haven't already. If you can't handle number 11 on your own, you've got to come see me in tutorials. You should look at that and immediately know that the slope is 5 and that the y-intercept is 1. For number 12, use what we know about standard form. I get that that's a negative 3 and that's a problem, but that's just somebody using bad grammar, so to speak. We can still do the opposite of a over b to find the slope, so that's the opposite of negative 3 over 4, which, when the negatives cancel, becomes a slope of 3/4. And for the y-intercept, we'll use the identity c over b. Check your notes. It's in there. It's what we did in class today. The y-intercept, c divided by b. Y-intercept is 1/2. For number 13, you're asked to find the slope that passes through the points 5, 4 and 3, negative 2. Well, use your notes. Change in y divided by change in x. Negative 2 minus 4 is negative 6. 3 minus 5 is negative 2. Negatives cancel. Reduce the fraction. Slope is 3. 15 is the same, but we've got the added step of writing a point-slope equation. Change in y, 1 minus 4, divided by change in x, negative 3 minus 6, equals negative 3 over negative 9, which reduces to positive 1/3. And now we can plug that into the point-slope equation. Again, go back and use your notes. Y minus y1 is equal to the slope times x minus x1. I'll take 5 or 10 minutes to answer questions to start a class, but then we'll get right to the test.